So you go once, you have to be either up or down to that place, below or above, then again. So it's like one circle up, one circle down. Like helix, but it's closed. It's totally closed. So first of all, as a 4 pi periodicity instead of 2. And secondly, I realized after several months of work, this thing actually is the edge of the Möbius strip. Because you see the edge and the surface itself. There is kind of duality there. And the third thing, it has a handedness. Everybody knows how to make a Möbius strip. So you have a long strip of paper, you join the end, but not glue them together, but rather twist it first, then glue. But you have two ways. One way is you do this, and the other way you do that. Then you get left-handed, right-handed. And I found this is the simplest object which possesses a parity. So this is more easily simplified by actually looking at the two Möbius strips, because it's in a mirror relation. So this one gives you one-handedness, the other one gives you another handedness. It's very easily done with the program, because earlier, before there was the program, it was very hard to imagine what is going on there in space. Yeah, and the reason I got this structure was that I once read this a cartoon book, and Sidney Harris, he said the trouble with Möbius is that things are only one side in every question. But I thought it was a question with me earlier was I did not realize there was handedness in this object. I thought there must be something very interesting associated with the structure. So then it comes to I call the postulate. I said the topological structure of the electron is a closed two-term helix, so just like that. That is generated by circulatory motion of a massless particle at the speed of light. So I made a MATLAB drawing here. So it starts out like this and one back like this. So then I try to see if the structure will give the properties of the electron. And the starting point was from here. So if a particle, if we call it electron, has a mass, and then it has a rest energy, and it also has a frequency and an h-bar. So then you can follow the de Broglie's quantization condition, where you have 2 pi r equals to the wavelength of the wave associated with the electron. And in this case, you just write 4 pi instead. So this one, and then you try to derive the radius of this helix in relation to Compton wavelength. And you get spin, you get magnetic moment, which will be, if you just think of a coil of current going twice, like that. So that's exactly the thing we measure here. Eventually, it's actually, well, I didn't do the rest. You will get charged times the radius. That's the end result. And then, now, if you have this structure, so we know that the electron and positron has a relation. The first thing is they both have the same mass, but in terms, because they have the radius here in the relation to their mass, the statement that they have the same mass will be equivalent to the statement of the radius, so they have the same size. And secondly, because one has a positive charge, one has a negative charge, that thing can be associated with the winding of your structure. So here it introduced a winding number and the parity. It's depending on which way you wind it right-handed or you wind it left-handed. So then I compare this formulation with the Dirac equation. So what you see is both will give you a spin and magnetic moment of the electron, and both has the association of electron and positron. And what about that is the spin node in the Dirac equation, it's actually the same as this helix, because both has 4 pi periodicity. In the case of the Dirac equation, you have 2 components describing electron spin up and down, 2 describing position up and down. But in this case, you have 2 structures, left hand and right hand. They can spin one way or the other. So you also have 4 states. And then there is this. I have said it's a circulatory motion. That one can be associated with Schrödinger's zeta-variable motion. Yeah, and what you get is you get one frequency which is the zeta-variable frequency, which will be twice as the de Broglie frequency of the electron. And then, well, with the structure and also phi structure constant. So I can derive also the phi structure constant, which will be the classical radius of the electron in the classical electrodynamics, and this radius will actually introduced here. And in terms of the pure geometrical relation, this is the radius of this one, and this is half width of this structure. So, but then by doing integration, because I told you the electron, the magnetic moment, this one, has been charge times the radius. All the concept above was based on like 2-turn, ideally like drawn structure. So one turn is complete overlap. But if in reality it's not possible to have, if both turns has the thickness, it's not possible to have them completely overlap. So then what I invent is if it's something like, you have to say you have first turn like this, large, and second turn is slightly larger than the first one, then the momentum like the whole value or the radius we measure should be the average of all the radii over 4 pi. So what you have is basically integrate over the angle from this one. So after this, you will get a relation where the R will be 1 plus alpha divided by pi, like this. And then this alpha will be defined as the half width of this structure to the radius of it. So it's like on one side, if you cut this one like this here, to one side it will be like this, the other side will be like this. Something like this, briefly. So that now, because we know alpha is E squared divided by h bar c. So if you have a geometrical meaning for this one, there must be a geometrical meaning for the charge, because I cannot find geometrical meaning for this one and that one. So that means, well, if you think, if you ask yourself whether this one is more fundamental, that one, or which one is more fundamental, or which one is less fundamental, that seems to me this one and this one is more fundamental, and this one is less. So then what you derive is you actually derive the charge square as exactly a twist of the structure. So it comes out like if you write it like this. So I will continue with this one. See, here I have gone a little bit, I try to explain where the twist comes from. So the twist will be eventually E squared divided by pi h bar c. So then you can associate charge or charge square with the twist of the structure. And then eventually you can also state that, say, that's based on Heisenberg's argument when he argued about the existence of fundamental length in the 1930s. He said, well, you have to have a fundamental length